Hello, everybody. So welcome to the Insightful Minds International Macro Rising Star Seminar Series. Today is our last day of the Rising Star series. So we will have two presenters. The first presenter is going to be Lingxuan Wu from Harvard University, and then the second presenter is going to be Federico from University of Chicago. So Lingxuan is quite productive. He already has a paper published at the Management Science. He also had papers under revision at Review of Economic Studies. So without further ado, I will let Lingxuan to start his talk.
Sure, yeah. Let's get started. I'm very glad to be here. I guess if COVID left us with anything positive, it's gotta be the webinar. So today I'm presenting this paper, which we call Thinking About the Economy, Deep or Shallow. It's my job market paper, and it's joined with my classmate Pier Francesco May. So we're gonna think about a systematic deviation from rational expectations. We start from a very simple observation, which is the economy is very complex. It involves long causal chains which contain feedback loops. Say there's surprise inflation, this is going to affect interest rate, which affects consumption and labor supply, which affects wage, which comes back and influences inflation again in the equilibrium. And then the feedback loop starts over. Traditionally, rational expectations assume that agents understand every causal step and loop when forming expectations. But there's much evidence indicating that people underappreciate how shocks propagate across the economy, and generally they have difficulty with causal reasoning when compared with the rational benchmark. So we're going to propose a simple theory which says that people only think through finite steps along the causal chain. Our first theoretical contribution is actually to represent any general equilibrium model as such a causal chain among variables, because this is not how macroeconomists are used to thinking about an equilibrium. Then we're going to measure how shallow people are. We run a qualitative survey, and we find that on average, people think through only 2.6 steps. And last, we're going to show that with such a simple yet realistic deviation from rational expectations, we go a long way in reconciling puzzles. And we can reconcile multiple puzzles that previously required separate explanations. So before I properly set up the model, let's just appreciate how complex our macroeconomy is. Even if I take the simplest textbook New Keynesian model, on the left, I'm showing you the causal chain representation of such an economy. Each arrow is going to be an aggregate variable, such as inflation, interest rate, or wage. And this graph depicts how one macroeconomic variable affects other macroeconomic variables. And the idea of shallow thinking is that agents know the shocks. For example, agents might know supply shocks or monetary policy shocks, but they don't fully think through how shocks propagate across the economy. And by truncating people's understanding at a finite depth, we speak to multiple puzzles with a New Keynesian model. First, we know that long-term nominal interest rates underreact to inflation surprises or changes in economic conditions, but they overreact to monetary policy shocks. So traditionally, we've got theories of underreaction and overreaction, but it turns out shallow thinking gives a unified explanation of both the underreaction and the overreaction. And furthermore, the empirical literature also documented that macroeconomic variables and macroeconomic expectations could predict bond access returns, even when you control for current yields. For example, it's shown that inflation expectations could negatively predict bond access returns, and shallow thinking is going to generate this. Last but not least, shallow thinking is going to predict that supply shocks will lead to higher inflation, and inflation is harder to control with monetary policy. We could also apply our theory to the real business cycle model. I'm not going to have time to talk about the RBC model today, but there we show that shallow thinking amplifies and prolongs business cycle fluctuations from productivity shocks, and it generates a stock market boom and bust pattern. All right, so now that I've overviewed the high-level idea of the theory, let me briefly contrast our theory with prior theories. There is this nice paper by Angelitos and Lian. They show that in a stylized environment, which the literature typically considers, Several theories, such as inattention or level K thinking, they're observationally equivalent. And the stylized environment can be thought of as, in our language, as having one variable and one self loop. For example, if you think about a Keynesian cross, the classic view on the Keynesian cross is just to say consumption amplifies consumption. So there is one variable and it is in one loop. Our contribution is to say that even the simplest New Keynesian model corresponds to much more complex graph. It's a longer causal chain, as I've just shown you. And we suggest that among all these causal steps, the further steps and longer feedback loops are going to be dampened more for expectations. It's going to be understood less. And this is going to be hugely consequential. More specifically, technically, we share the same technical apparatus as level K thinking or partial equilibrium thinking, if you know this literature. But as I've alluded to, they apply level K thinking to very stylized environments with one variable. And let's know that the notion of level K thinking is like Nash equilibrium. It is an incomplete assumption until you specify the game, the players, and the actions. So the devil is all in the details. That's how we differ. Our first contribution is actually to show that our classic macro model corresponds to a much more complex causal chain. And with such a longer causal chain, we can explain why beliefs overreact or underreact to different shocks. And further, we can even flip the equilibrium impulse response relative to rational expectations. Whereas a lot of the prior theories, they only change the magnitude relative to rational expectations, but keep the same sign. There are, as I've alluded to, there are separate theories of underreaction and overreaction. Shallow thinking is going to generate both. Roughly, the intuition is that if you think about a belief of one variable, you would have belief overreaction if this variable is in a very long offset loop, because our agents is going to underappreciate the long offset loop. Whereas if you think about beliefs of one variable in response to shocks that hit other variables or other parts of the economy, you would observe underreaction. And last, there's a large literature that keep rational expectations but introduce information frictions. Our paper is broadly complementary with these papers because we study, conditional on knowing the shock, do people know how shocks propagate? And we're going to provide very unique evidence in support of our channel. If you have any questions, please just ask. I saw someone raising their hand.
Oh, yes. Can you hear me?
Yeah.
So, yeah. So I just wonder, is this theory of this shallow thinking observationally equivalent to, say, models with incomplete information, which can also give you over or under reaction?
It will not be because I'll just give one example. Once we get into the details, we can discuss through more. Roughly, theories of information friction, for example, Mankiw Race or other papers, they would say that some people know the shocks or people know have a noisy observation of the shock. Then in this cases, like your expectations might uniformly underreact to all shocks or uniformly overreact to all shocks, but they don't have differential misreaction to different shocks. And as a result, when I talk about the inflation application, I'm going to show a special case where under rational expectations, there will be deflation. Under our theory, there will be inflation. And under a lot of existing theories, such as inattention or information frictions, there will also be deflation. So they have the same sign as the rational expectation equilibrium. Does that make sense?
Yes. I'm just thinking that if you have, a rational expectation model where information is incomplete, you can kind of twist agents' information set to almost produce any type of inflation response you could have. So observationally, it's very hard to identify which mechanism is present.
Right. I think I do view that as sort of yes, to some extent, but I would say that's pushing like information frictions a bit too far in that if you allow me to generate like arbitrary information structure, you can do a lot of things, but then the question becomes empirically, is that relevant? When we test our theory, we're gonna strictly mimic an environment in which information friction is not gonna play a role. So I'm gonna tell people about shocks and ask them, given this shock, how do you think the shock is going to affect the economy? So, and I'm going to make the bar extremely low. So in our survey, I'm going to ask people, in response to monetary policy shocks, will consumption go up or go down? Will inflation go up or go down? So it's all directional. And our theory would tell you when is the case that people get the directions wrong. Whereas it's very hard to get this if you think about information frictions. First, sorry, my light went off, which is kind of dumb. All right. Okay, so I mean, let's come back to this when I get into the details of the model. Because it's this discussion can be a bit too abstract without writing down the specific model. So let me go ahead. So roughly, I'm gonna talk about all three parts of the paper in this talk. So first, I'm gonna set up the textbook New Keynesian model and introduce shallow thinking. And then I'm gonna measure shallow thinking using a qualitative survey. And last, I'm gonna talk about the consequences. So let me start with the New Keynesian model. So let's recall that the textbook New Keynesian model is gonna feature three types of agents: firms, households, central bank, and a labor market. So I'm gonna set up the model in a way that's slightly different from maybe what you're used to, and I'll explain why. The specific scenario I'm gonna think about is that I'm gonna consider a transitory news shock. So in period 0, I'm gonna tell you there's a shock that's gonna realize in period 1. And for today, I'm gonna solely focus on this transitory news shock. Our theory could be extended to persistent shocks, but the intuition is it's more or less the same. So with this news shock design, what happens is that since the textbook New Keynesian model is purely forward-looking, starting from period 2, the economy is going to go back to equilibrium. It's going to go back to steady state, and our agents understand that. So in period 1, when the shock realizes, I'm going to allow everybody to observe the period 1 outcomes. So the best response to what they observe, the period 1 economy is just like a static general equilibrium. Now, if you go back to period 0, in period 0, the shocks have not realized, but the shocks are known. So agents are going to form beliefs about period 1 outcomes. And since households and firms are forward-looking in the textbook New Keynesian model, so this news shock is going to affect the period 0 equilibrium solely through people's expectations of period 1 outcomes. So with such a design, we can do two things. We're going to compare period 0 expectations of period 1 outcomes against the actual period 1 outcomes to show you how beliefs misreact to different shocks and to explain bond market puzzles. And then I can also study the period 0 economy to show how shallow thinking affects inflation dynamics in period 0, for example. And throughout the talk and throughout the paper, I'm going to log linearize the model around the steady state. So everything is going to be to the first order. Now, I'm not going to use the usual 3-variable representation that you might be used to. Instead, I'm going to introduce an alternative representation, and I'll justify why. But roughly, it's going to go as follows. I'm going to think of the labor markets as operated by auctioneers, and I'm going to characterize the whole model as the system of best responses of all agents, including firms, households, central bank, and the labor market auctioneer. With that, let me go start with the real agents in the economy. So in the economy, in period 1, every agent observe the relevant variables for their decision. Firms are going to choose dividend, labor supply, using a linear production technology, and they set prices in a Colville manner. So in terms of the dividend would be higher if the aggregate demand, which is consumption C1, is higher. And dividend would be lower if the real wage W1 is higher, because firms need to pay more to hire workers. Mu is going to be the steady state markup. Firms are going to hire laborers to produce, since they operate a linear production technology and they produce to satisfy demand. So the labor demand firm post is going to be equal to consumption C1. To anticipate our analysis of the labor market later, I'm going to think of the labor demand as a demand curve. In this particular model, labor demand does not respond to wage because labor is the only factor used in production. But for generality, I'm going to think of this as a demand curve that shifts by n hat and has an elasticity E, which happens to be 0 in this model. So the demand shift is going to be equal to consumption C1. So if aggregate demand, if consumption C1 is higher, firms need to hire more workers, which is to say that this is the shift in the labor demand curve. And last, firms are going to set their prices. So in a classic call pricing model, a share of firms will be able to set their prices, not everybody. For those that will be able to set their prices, they're going to set their prices proportional to their nominal marginal cost. So if you think of a continuum of firms, only part of them could set prices. And if we aggregate this part of firms that could set their prices, we could write down aggregate inflation as a function of the nominal marginal cost. And here I'm going to decompose the nominal marginal cost as an additive sum of the real wage W1 and aggregate inflation pi1. And as usual in a New Keynesian model, I'm going to insert a supply shock, which is a shock that exogenously move the prices. Think of a shock to the markups, which is going to be the supply shock we think about. And the form of equation 3 is very interesting in that you might see that the aggregate inflation pi1 appears on both sides, but I'm not going to cancel this off. You could cancel this off, in which case it reduces to a familiar New Keynesian Phillips curve. But the reason I'm not doing that is I want to preserve the form of equations as best responses. If each individual firm responds to real wage and the aggregate inflation, I'm going to keep this best response, as if aggregate inflation responds to the real wage and the aggregate inflation itself. Now, let's think about households. Households in this economy choose consumption and labor supply. So what they face is that they're going to face the interest rate I1, they receive a dividend D1, and they face a real wage from the labor market W1. Consumption is going to be lower if inflation is higher. Consumption is going to be higher if dividend or wage is higher. Households also choose their labor supply. Like similar to what we did with labor demand, I'm going to think of labor supply as a supply curve. Because in deciding labor supply, agents optimally respond to the interest rate, the dividend, and the wage. I'm going to think of the response to wage as the supply elasticity, which is positive in this model. So if the wage is higher, households are going to work more. Whereas I'm going to think of the response to interest rate and dividends, which are all the variables that is not the wage, as a supply shift, right? If dividend is higher, people are going to work less, which is a shift in the labor demand curve. I'm going to think of this households as choosing the labor supply shift, which is given in this green part. Last, there is a central bank in this economy that sets a nominal interest rate according to a standard Taylor rule. And here I could consider a monetary policy shock. Throughout this paper, I'm going to think of a cost push shock and monetary policy shocks as that sort of a classic demand and supply shocks, but it's extremely easy if you want to add other shocks. Now, to close the model, remember we have a labor market that pins down the real wage in equilibrium. I'm going to postulate the labor market is operated by an auctioneer who finds the real wage, who decides on the real wage in response to supply and demand shifts. So this is capture your Econ 101 intuition that price results from supply and demand. So wage is higher if labor demand is higher, wage is higher if labor supply is lower. So you can really think of wage as the choice of a labor market auctioneer, and the labor market auctioneer responds to supply and demand shifts, which are chosen by firms and households respectively. Now, why do I do this? Because this gives me the best responses of all agents, and this characterizes how one macroeconomic variable depends on other macroeconomic variables. So if we collect this system of equations 1 to 7, we could form a fixed point system. And each partial derivative in the equation 1 to 7, I'm going to call this a causal relation, because each equation tells me how one macroeconomic variable depends on other macroeconomic variables, right? For example, consumption depends on the interest rate and dividend and wage through the household's response. The interest rate depends on inflation through the central bank's response. Inflation depends on real wage through the firm's response. And the real wage depends on supply and demand shifts through the labor auctioneer's response. if we collect all these variables, all the 7 variables that are relevant in the model into a vector v1, I can write down this fixed point system as if v1 depends on other subcomponents of v1 through this matrix M, which I call the causal relations among macroeconomic variables. And in addition, v1 are subject to shocks. So these are the interest rate shocks to the interest rate and the cost push shock to inflation. And each equation in the system represents a causality, with the outcome variable on the left and the causes on the right. And we can rigorously translate such a fixed point system into a graph, which I've shown you in slide 2. But here, we've properly microfounded this graph because we could represent each agent type, such as households, firms, the central bank, as well as the labor market auctioneer, as a node in this graph. And I'm going to write down each variable, which is a decision by some agent, as an arrow in this graph. This graph is just depicting how one variable affects other variables. For example, firms are going to choose inflation, which are the prices. Inflation affects interest rate through the central bank's response. The interest rate affects households' behavior, and households' behavior have further effects on firms and on the labor market. And what are the shocks? We study 2 shocks. One is a cost push shock, which is a shock that hits firms. And if you think about monetary policy shock, it's just going to be a shock that hits the central bank. So these are how we introduce the shocks to the graph. Later, I'm going to show you how agents sort of reason with this graph in an incomplete way. All right. So now before I get into our sort of theory of shallow thinking, let me briefly touch upon why we use this particular representation with 7 variables rather than the familiar sort of 3 variable representation of a New Keynesian model. So our equations 1 to 7 are going to characterize the dependence among variables through agents' best responses. So for example, consumption depends on interest rate, dividend, and wage, and inflation depends on inflation and real wage. Now, traditionally, people use a 3 variable representation of a New Keynesian model. In that case, I put down the equations here, but the details is not super important. But in that case, let's notice that how we think of, say, the Phillips curve. Traditionally, people think about the Phillips curve as inflation dependent on the consumption or the output gap, if you will. Now, the problem with this representation is that in deriving this, you already used a lot of variable substitutions. So you've already baked in the dependence of wage on the output gap, which only holds in equilibrium. In fact, any alternative representation that's not our equations 1 to 7, already mixing relations that only hold in equilibrium. So they're not strictly best responses. There is a unique way of writing down the general equilibrium model as best responses, which is what we do. And the advantage of doing this is that this gives you a clear sense of what the causal chain is, what the causal steps are. If you do a lot of variable substitutions, in our world, you're basically collapsing multiple steps into a single step. That's harmless under rational expectation. That's harmless if agents understand every step, but it's obviously problematic if agents are shallow. So with that, let me head towards defining shallow thinking. So if recall that we can express the period 1 equilibrium, the period 1 static general equilibrium as a fixed point, and we can solve this fixed point as just infinite sequence of, it's just going to be a geometric sum of many terms. And we're going to introduce shallow thinking as follows. We say that each term with m to the power of n minus 1 represents an n-step effect, which is how shocks affects one variables through n minus 1 other variables. We're going to say that shallow thinking agents, when they start from the shocks, they only take a finite number of steps. They don't fully appreciate every causal step. So that's to say that if there's a supply shock, adapts 1 agents understand that inflation will be higher. Adapts 2 agents understand that in response to higher inflation, the interest rate will be higher. Adapts 3 agents further understand that higher interest rate is going to lower consumption and raises labor supply. And adapts 4 agents will understand that changes in household behavior will have further effects on firms and labor markets and so on. So know that our shallow thinking agents are really make two belief mistakes here. There is a qualitative mistake and there is a quantitative mistake. There is a qualitative mistake in that if I don't take enough steps, I might not appreciate changes in certain variables. If I'm too shallow, I think about inflation response to supply shocks, but I don't think about the interest rate response. Now, our agents could also make a quantitative mistake in that if they don't take enough steps, they don't correctly appreciate the strengths of such loops, right? There are feedback loops in this economy that by definition takes infinite amount of steps to fully appreciate. Our agents, when they take finite steps, they're gonna misforecast the strengths of such loops. And how do we measure this? Our model implies that shallow agents only understand changes in variables that are closer to the shocks, right? We can define a notion of variable distance, which measures how many steps does it take for each variable V to be affected by each shock S. And what our theory says is that when agents make qualitative mistakes, they are gonna only understand changes in variables that are shallower than the number of steps that they can take. So this will allow us to measure people's steps of thinking later. I'm gonna formalize this in a few slides. I'm gonna place additional some.
I have a question. So how do you define a step?
Right. So a step, I was giving you a sort of a graphical intuition, but rigorously, a step is just an iteration of this system, right? Because the true equilibrium has infinitely many terms that captures many n-step effects, whereas our n-step agents only think about the first n steps, which is they only take n steps on this graph.
Right. And then if you want to quantify how many steps that these agents have when thinking about the economy, but then the question is how what if the agents who has never taken a macroeconomics class, he doesn't even know that all this doesn't even know this model, even it's the simplest New Keynesian model.
Right. Excellent. I'm glad you asked because later when I introduced their survey, what I asked them to do in the survey is that I asked them to forecast directional responses of different macro variables in response to different shocks. I'm not imposing any particular way for them to do their forecast, right?
Right.
What I'm saying is exposed after I collect everybody's data, I could use my notion of this model implied variable distance to explain whether each individual's forecast is correct. So it's very plausible. A priori, it's plausible that agents don't think sort of in a similar manner, but that's
Right.
not the case. So we're gonna show that people roughly follow sort of the similar sort of causal graph as we macroeconomists write down. And the way I think about it is not that agents have to necessarily take a macroeconomics class, which, I mean, if they do, that's obviously good. The way I think about it is that macroeconomists write down this causal relations, write down this economic relations to capture intuitive forces in the economy, right? If you ask people about supply shocks, people naturally think about think about inflation. If people watch news, they know that when inflation is high, interest rate is going to be high, right? So these are, in my opinion, sort of the natural association among variables.
So do you say it's, the agents are not necessarily know the model, but those causal relationship there would be like already embedded in the model. So even they don't know the model, it's okay. But as long as they know some of the causal relationship.
Right. But later when we apply our theory, I'm gonna assume that they know the model, right?
Okay. But I think you are on the optimistic side. So yesterday we had another candidate from like Berkeley, like Bernardo Candia. What he said, they have this survey through the Nielsen, like and then what they said is that many of the surveys seems like the people who get surveyed doesn't even know the concept of real interest rate, because in their survey they provide the inflation expectation, they provide the nominal interest rate, and then they ask people to respond what is the real interest rate. And many people didn't know how to do the calculation. So basically that means that many like people don't even know the concept. So I think
Right.
the
Yeah,
pessimism.
I agree. I mean,
Yeah.
in that particular case, it's trickier in the like whether we actually measure people's financial literacy, like in our survey too, and their financial literacy correlates with their ability to understand shock propagation in the macroeconomy, which it's sensible to me. In that particular case, I guess like then the question is like, how do people actually make their decisions? Do they reason with real interest rate, or do they just think about inflation as interest rate separately? Because you don't have to reason with real interest rate, right? But I take your point. Like in fact, what we show is that people are pretty shallow. They take like 2 steps at most. It's not like they can fully think through the graph.
Sure. Okay.
All right. So the second assumption we place is to make our theory parsimonious. I'm gonna assume that the depth of thinking follows a geometric distribution with a continuation probability lambda. So everybody could take 1 step, lambda sure takes a second step, and lambda square sure takes a third step. And lambda is gonna be the only parameter that's needed to apply our theory, with lambda equal to 1 nesting ration expectations. And in the second part of the paper, which I will only sort of briefly walk you through, I'm gonna measure this lambda. And once we measure this lambda, I'm gonna use this lambda to generate all the beliefs in our model and to apply our model to classic, say, New Keynesian model. And it turns out that in our model, once I place this geometric distribution, I can characterize the average expectations as follows. So the average expectations takes into account all the n-step effects of shocks on variables, but with the further effects dampened more, just because fewer people are gonna go that far. And the average expectations could actually be characterized to follow a fixed point as well. So that's to say that average expectations are generated as if by representative agents who is aware of all the causal relations in the economy, but dampen them by lambda, right? If lambda is 1, then this average expectations coincide with the true equilibrium outcomes. If lambda is 0, then people don't understand at all how variables affect one another. And this is a formula that coincides with a prior paper I have. So in this current paper, when I measure lambda, I'm going to measure this off households. But in the prior paper, I take this formula and I show that there is a way for you to extract the empirical moment from professional forecasters. And I suggest that even professional forecasters are subject to similar bias. So they underappreciate the cross-variable relations. The point of this is to say that lambda is the only parameter we need. So the second part is going to measure lambda. I'm going to go through this part very quickly in the interest of time so that I reserve some time to talk about macroeconomic dynamics. So to measure this lambda, I'm going to give you the intuition, but here is the formalization. So the intuition is that if we place some additional regularity assumption on the model, what I would find is that in response to shocks, if you think about forecast of different if you think about reasoning of an agent, so as each agent gets deeper and deeper, so as you go from the shallowest agents to deeper agents, there will be some depths of thinking where that agents begin to acknowledge changes in this variable, because this guy takes enough steps for you to appreciate that this variable will change in response to the shock. In our model, in our classic New Keynesian model, it's the case that once let's say the depth 3 agents understand the changes in, say, interest rate, the changes in consumption to supply shock, everybody deeper than this person will also get the directions correct. Whereas everybody shallower than this person will not get the direction correct. So in order, this gives me a way to measure people's depth of thinking. And the way is like follows. So I'm gonna get a group of respondents, and I'm gonna ask them to provide directional forecast of macro variables to macro shocks. Like I literally ask them if there's an oil shock or if there's a monetary policy shock, will inflation go up or go down, will consumption go up or go down? And our theory predicts that the combinations of variables and shocks that are further apart are gonna be understood, are gonna be correctly appreciated by fewer people. And we can run a rigorous regression like follows. So I could determine whether each individual's forecast of variable V to shock S, whether this is directionally correct by comparing this person's forecast against empirical benchmarks. So I'm gonna have an indicator function, which I call correct directional belief. It's gonna be 1. if belief is correct, if it's going to be 0 if belief is wrong. And it varies across agents, across shock, and across variable. And our theory predicts that the conditional expectation of this indicator, conditional on the variable depth being D, is geometrically decaying in the variable depths. So that's to say that if I run a regression, if I run an OS regression of correct directional belief on variable distance, I'm going to uncover a negative slope beta. And if I run a nonlinear least squares by fitting a geometric function, I can exactly identify the key parameter lambda with the coefficient B2. And this is what we're gonna do. And in the survey, we ask people about different shocks. We ask them to forecast directional responses of different variables. So this gives you a sense of the model generated variable distance as the number, and it gives you the sense of the true directional response as in the arrow. And I'll just say that this directional response of variables to shocks in response to different shocks, say oil shocks, monetary policy shocks, government spending shock, personal income tax shock, and other shocks, these are pretty fairly well established in the empirical literature. And I'll just quickly show you this graph to give you an idea of how this measurement works. So this graph plots the regression, the OS regression, where it plots sort of the indicator of correct directional belief against the variable distance. And this blue dot is sort of the raw, is just the raw scatter plot, whereas this red diamond is going to represent sort of residuals after I control for a lot of fixed effects. But you can see that the magnitudes, the findings are more or less the same. The way to read this graph is to say that in response to shocks, many people, almost all the people could get the first step, whereas only half of the people could correctly get the direction response of the second step. Very small share of people could get the third step. That's to say, if I have a supply shock, everybody's going to understand that inflation will go up as the first step. Only part of the economy, part of the population understand that as inflation goes up, interest rate will go up. If you take the third step, which is if interest rate go up, consumption will go down and labor supply would go up, a very, very small share of the agents will understand this. And we will be able to measure the key parameter lambda by fitting this slope, right? Because the key parameter shallowness lambda governs the distribution of people's forecasts. It corresponds to the slope from a very intuitive sense. If everybody is as deep as it gets, if everybody's rational, if lambda is 1, then the slope would be 0 because every directional belief would be correct. If people are very shallow, if everybody can only take a first step, then you would observe that starting from the second step, the conditional probability of getting beliefs correct would be 0. So, whereas we find an intermediate case, and our calibration suggests that on average, people takes about 2.6 steps. There are a lot of empirical exercises that we do to speak to sort of confounding other explanations of belief heterogeneity, but in the interest of time, let me skip this part. So I have 20 minutes left. I want to talk to you about some asset pricing puzzles and some macrodynamics. Okay, so now that I've measured this parameter lambda, the rest of the paper is just gonna plug this lambda and use our theory to talk about sort of to see how it changes the behavior of our macro models. I'm gonna follow a standard calibration at quarterly frequency for the new Keynesian model. All parameters are standard. The only additional parameter we introduce, as I've said, is this belief parameter. I'm gonna say that lambda is about 0.61, which is from our survey evidence. And that means that people on average only think through 2.6 steps. Now, let's think about how shocks propagate in the economy. So we're gonna think about a period 1 economy. Recall that in period 1, shocks realize people observe every variable that's relevant for their decision. So the period 1 economy is a static general equilibrium. Now let's think about supply shock in period 1 economy. So this equation gives you the true equilibrium inflation response in period 1 in response to a supply shock. And the way to read this is to combine with this graph. So with this graph, I'm going to show you that there are multiple feedback loops in determining inflation response to a supply shock. And in particular, inflation response is directly involved in two of the loops. First, there is a one-step loop, which I call pricing complementarity. That's basically the idea that if aggregate inflation goes up, holding fixed the real wage, each firm's nominal marginal cost goes up. So each firm wants to raise prices further. That's to say, aggregate inflation amplifies itself through this one-step self-loop. Now, there is another loop depicted in orange. That's an offsetting loop. It involves monetary policy that goes as follows. As inflation gets up, the central bank is going to raise the interest rate, which is going to lower households, which is going to lower consumption and raises labor supply, which is going to lower real wage. As the real wage gets lower, inflation gets lower. So this loop going through 4 steps through the monetary policy response is going to offset the inflation response to supply shocks. And in particular, there's this third loop depicted in gray, which is the classic Keynesian cross, which embeds the idea that anything that changes household consumption is going to have further amplification by invoking sort of the interaction between household and firms. So in this case, this Keynesian cross term is going to compound with this monetary policy loop, which is given by this multiplication. Now, how do our shallow agents understand this economy? So in period 0, they are aware of the shock in period 1, and they're going to form beliefs about future outcomes. I show that their average expectation of period 1 inflation follows this equation. And in particular, you can see the modification relative to the true equilibrium response through this lambda and lambda to the power of 4. That relates to how agents understand the causal loops in the economy. For a loop that takes 1 step, whenever you go through it once, only lambda share of agents remain. So in terms for the average expectations, it's dampened by lambda. Whereas for a longer loop, it's understood by fewer people, so it's going to be dampened by even more. Since it takes 4 steps, it is going to be dampened by lambda to the power of 4. So this is how shallow thinking penalizes different feedback loops in the economy for expectations, with longer loops penalized more. Now, this is the expectation regarding the interest rate. We could also see the expectations regarding, this is the expectation regarding the inflation. We could also see the expectation regarding the interest rate. The equilibrium interest rate I1 is going to be proportional to equilibrium inflation pi1 from the standard Taylor rule. Whereas the expected interest rate is going to be lambda times phi times the expected inflation. There is this additional lambda since it takes one more step for people to understand that inflation affects the interest rate. And this additional lambda is going to be crucial for some of the implications we'll talk about next. Now here, while we're here, let's just note a very extreme case. If people are very shallow, if lambda is 0, that means people only take 1 step. So they will believe that future inflation will have the same magnitude as the supply shock, whereas they don't perceive any changes in future interest rate. So that's the extreme case to say that if people don't perceive any propagation, they don't understand the feedback loop of the inflation response to the supply shock, and they don't understand changes in any other variable. Now here, I plot you the expected interest rate in period 1 as a function of lambda. So as I vary lambda from 0 to 1, this is how the average expectation of interest rate changes. And in particular, in this green vertical line, this is the rational expectation, which corresponds to the true equilibrium interest rate. Whereas this blue line corresponds to our calibration of shallow thinking. So it's the average expectation in our model. And you will see that the average expectation of future interest rate underreact compared to the true equilibrium response. And in our model, if you have a long-term asset, if you have a long-term interest rate, the long-term interest rate is going to be driven by expectation of future short-term interest rate. So this generates the underreaction of long-term yield in response to supply shocks, which is observed in the empirical literature. Now, if I think about inflation expectations, now I'm gonna plot inflation expectation in response to cost push shock as a function of lambda again. But now you know that this line is no longer monotonic. And in particular, this shock has a size of 1. So if agents are very shallow, they would perceive inflation response to be 1. But when people are sort of partially shallow under our calibration, they would perceive inflation to be amplified relative to the shock. Whereas the true inflation indicated by this green line, it's offset relative to the shock. Now, the reason this happens in our model is because recall that on the last slide, we saw that there are two loops that govern the response of inflation to supply shocks. There's a shorter loop that amplifies the response, and there's a longer loop through monetary policy that offsets the inflation response to supply shocks. Our agents understand the shorter amplification loop better than the longer offsetting loop. So on net, they're going to perceive amplification, which is why they perceive an inflation response that's larger than the size of the shock. Whereas in reality, the longer offsetting loop involving monetary policy is stronger. So that's why at equilibrium, inflation would actually be offset. So that's to say that our agents, they overreact. So in response to supply shock, their interest rate expectations underreact relative to the equilibrium, but their inflation expectations overreact relative to the equilibrium. And there is a bit of synthesis that I can provide here, which is to say that our model predicts underreaction in the following case. When you think about a variable, say, if I'm interested in inflation expectation. Sorry, if I think about a shock that hits other part of the economy, I'm gonna observe underreaction. Recall that I suggested that in response to supply shocks, interest rate expectation underreact. Now our model generates overreaction when you think about beliefs about a variable in response to shock that hits itself, right? I've just shown you inflation expectation overreact to supply shocks. That's because agents underappreciate the offset loop on inflation. And here is how our theory differ from other theories. So many theories generate pure overreaction, say extrapolation, or pure underreaction, say inattention or information friction. Whereas our theory generates sort of a flexible pattern of over versus underreaction, depending on the shocks that you look at. Now I can think about other shocks.
So you're comparing with other mechanism. How would you compare it against the cognitive discounting by the Gebex?
Right. In that model, so there will be first, it tends to generate underreaction in that people are sort of underaware of shocks, or they're underaware of future condition, right? If I tell you about a shock in the future, if you're a cognitive discounting, then you just underappreciate what's going to happen in the future. Right. And moreover, your expectations of different variables would uniformly underreact to the same shock, right? Say, think about our inflation supply shock in the future. You would understand inflation will go up, interest rate will go up in the future, but you uniformly dampen your expectations. Whereas what we show is that in this particular case, interest rate expectation underreact, but inflation expectation overreact, right? So this generates, for the same shock, expectations of different variables misreact differently. And this will have important sort of macro consequences later, as I'm going to show.
Yeah, my understanding is it's always, what do you say? It's overreacts to its own shock, but it underreacts to the other shock.
Exactly.
Then how about the different horizons? Is it possible to generate that the overreact at the short horizons, but underreact at the long horizons, or the opposite case?
There are certain theories that do that regarding the horizon. Right. It's not a focus of our theory because we in this specific stylized example, like this two-period example I shown you, there is no like real true dynamics in the long run. But when we generate our model to dynamic environments, we're gonna think about the causal relations across variables. We're gonna abstract away from the intertemporal dimension. So this will not be the part of the sort of the baseline theory.
Okay, thank you.
But there are certain theories that that's a bit more complex. Say there's like theories of sort of natural expectations by Leibson and Herbert and Foster. They would but they don't work with sort of any general equilibrium model. They work with pretty stylized models. What they do is to say that if the shock is actual, if the true process is AR1, but people try to sort of fit if the true process is AR2, but people try to fit an AR1 process to forecast that, it could generate different misreactions. But that's a prediction very unique to sort of a specific process you think about. Whereas our theory tries to apply to sort of any general equilibrium model and any shock you want to think about.
Okay, thank you.
Good. So that's the lesson about supply shock. There's a similar lesson about interest rate shock. So here, if you shock the interest rate, it is an own shock for interest rate expectation, and it becomes a cross shock for the inflation expectation. So here you would have the interest rate expectation overreact to monetary policy shock. That's again because it's in an offsetting loop. As interest rate goes up, equilibrium inflation goes down. This triggers the central bank to slightly lower the interest rate going forward. As our agents underappreciate this offsetting loop, they're going to overshoot their interest rate forecast. So this leads to an overreaction of long-term interest rate to monetary policy shocks. So this is how we're sort of generating the seemingly opposing findings in the literature, which is that for the same object, which is long-term nominal interest rate, it's overreacting to monetary policy shocks, but it's underreacting to other shocks. Now, our theory would also generate predictability of bound access returns. I'm not going to have time to talk through this, but I'll just give you the high-level intuition. That's to say that if you want to, previously, what the perspective we had, it's unconditional response to shocks. Now, if you don't know what are the shocks that hit the economy, if the economy is subject to multiple shocks, if you simply run a regression of bound access returns on current yields and on macroeconomic variables, our theory suggests that the current yields primarily load down people's interest rate expectations, whereas macro variables primarily load down, say, the macro shocks. And this gives you additional predictive power of macro variables on bound access returns, even when you control for the current yields, which mainly reflects interest rate expectations. Now, I want to briefly sort of wrap up this asset pricing part and reserve a few minutes to talk about macro and some potential future research. So as I've suggested, we generate over and under reaction to different shocks. We generate bound access returns, and we could speak to some other puzzles in the literature as well. I'm not gonna go through this part in greater detail, but I'll just briefly mention one finding we have, which is we're gonna suggest that if you have a shock, a news shock about a future contraction in supply, which is say a new NVIDIA comes out and announces that next quarter they're gonna raise their prices out of the blue. Our theory predicts that you would observe inflation in the current quarter, whereas rational expectations and many other theories, for example, cognitive discounting, would predict deflation. And our theory further predicts that if you have a persistent cost push shock, it's going to be more inflationary than under rational expectations and under other theories. And inflation is going to be harder to control with monetary policy because people don't fully understand how monetary policy is going to respond in the future and how responsive monetary policy is going to dampen inflation. So I'm already slightly out of the time. Let me try to wrap up. So in this paper, we provide a theory, measurement, and consequences of shallow thinking. Our first theoretical contribution is to depict the macroeconomy as a long causal chain, and we suggest that the further causal steps and the longer feedback loops are going to be perceived by fewer people. We show that the average depth of thinking is only 2.6, and we could use by truncating people's understanding, we could speak to multiple asset pricing puzzles, and our theory makes a different prediction on inflation from rational expectations and existing theories. Now, in the last minute, let me give a sort of a even higher level overview of this project and where I see this agenda could go in the future. So in this current project, we'll apply to shallow thinking to the workhorse New Keynesian and RBC models, and we focus on the qualitative and the positive aspects. Now you could apply our theory to other models. For example, if you have a production network or if you have a financial market with multiple assets, you can think about how agents understand how shocks propagate through these networks. If you have a model of the world economy, you can ask, say, what if China is shocked or Ukraine is shocked? How does this affect the world? How does this affect other countries? You could use this. In fact, I propose a procedure for people to apply this to any quantitative Hank model. You could also do business accounting with our shallow thinking theory. This has sort of very obvious normative implications. This changes the conduct of monetary and the effectiveness of monetary policy. We don't study fiscal policy, but it's possible to do that. And last, you could even apply this model to other fields because at the end of the day, we're just providing sort of a plug and play model for general equilibrium model. For any sort of other models in other fields, that is a general equilibrium model. You could use our model to think about how people could realistically understand complexity. For example, it's very popular for people to building sort of spatial models to assume rational expectations. But that's very demanding in saying that anything that happens, say, I'm in Boston, anything that happens in, say, Texas, will have some implications for Boston because people are going to migrate, prices are going to adjust, rents are going to adjust, wages are going to adjust. But to what extent do I understand that? It's obviously a very complex forecast problem for me to do. And the shallow thinking might provide a sort of a useful and realistic deviation from rational expectations. Good, that's all I have for today. I'm sorry to be slightly over time, but it's a pleasure presenting this project to you.
Okay, so thank you very much for the great presentation. I think we are a little bit flexible in time because we only have two presenters. So you mentioned a lot of like future works, but let me be more specific and ask just one more question. So because most of the people here might be the first time to learn what is the shallow thinking. So we can hardly, in your paper, is a part of it is the theory part of it is the application part. So we can hardly develop something new to extend your theoretical part, but it's possible for us to apply your stuff in a practical issue, for example, to explain a puzzle in international economics. So now my question is, okay, so in my purpose is to explain a puzzle in international economics or international finance. For example, the relationship between interest rate and foreign exchange excess return. Then what kind of data do I need? So do I need to send a survey to everybody I can get the individual forecast, or I just use a consensus?
Right. I think there are different things one could do because in applying this model, in a sense, you just need sort of what we provide is just a structural deviation from rational expectations, right? It's governed by this particular parameter. We estimate this parameter by running a survey, but you could plausibly estimate the parameter like by fitting the data, right? If you say that this is a plausible structural assumption on expectations, like you would do, like suppose you have any other sort of addition to a model, you could just try to estimate this parameter together with other parameters to jointly fit some moments. That would be a plausible way as well.
Oh, okay, I see.
But I guess, I mean, ultimately, the part of the purpose of we doing this survey is to provide evidence, right? Because this is a structural assumption. We don't want to like just to take it as is. We want to test whether it's a valid assumption. That's why in the survey, we're trying to show you that even for the same variable, when it's further away from the shocks, it's understood by fewer people. So that's us trying to test the structural assumption.
Yeah, so my understanding is that if you have this survey information, it would be great. But if you do not, you just use this.
There will be other ways to estimate this.
Moments, right?
Yeah.
And then so what are the steps that we should follow to explain a puzzle? So generally speaking, it's kind of like a tutorial to people. And another thing is at which point you can release some like example code that can show how to do the
right. So I mean, there is a sort of a conceptual and more like practical. There are, I guess, two issues. On the more conceptual side, the paper basically has a sort of conceptual procedure for you to apply this to any general equilibrium model, right? Like this procedure is for you to think about what are the agents in the model and what are the markets in the model. For markets, you have to cast markets as well as regional auctioneers. And then this gives you a set of causal relations in the mod that describe the economy that you can sort of iterate with to generate the expectations. There is a sort of a practical point, which is how to implement. I do this fully analytically in a New Keynesian model, but in a lot of complex models, you don't really have the analytical convenience. But I do provide one sort of there is one appendix that shows you if you are aware of sort of what's called the sequence space Jacobian solution. So it's a popular solution to solve heterogeneous agent models, including say macro models or international macro and finance models. So there is, if you know how to use that toolbox, there is a natural way for you to plug in our theory in that toolbox. So it's built on their sequence space. There's a procedure for you to sort of use this theory.
Right, I see. Yeah, that's some useful additional information.
Yeah, because actually we at some point I applied this to Hank. It didn't ultimately make into the paper, but the idea is ultimately about like sort of how variables depend on each other. It's just like it's always there, like given any model, be it a representative agent model or a heterogeneous agent model. They just embed slightly different causal relations. I think there is a question by the audience.
Yeah. Yeah, you can. We can have one more question.
Okay, let's take that and we'll wrap up.
Yeah. Okay.
So it's my turn, right? Ren?
Yeah, please go ahead.
Yeah, go ahead.
Yeah, so I kind of buy the story, which I mean the theory of shallow thinking, which I think is quite intuitive. My question is, have you thought about some deeper reasons behind this sort of reduced form shallow thinking? For instance, is that because of the limitation on people's cognitive ability, or just the lack of information, or some other reasons that people are unable to think deeper?
Right. I think it's unlikely because of information, because again, our perspectives on like given your information of the shock, how do you think shock is going to propagate? But there are different possibilities underlying why people sort of don't think through all the steps, but rather feel like they only perceive certain steps. One interpretation, we don't take a particular stance, but one interpretation is just behavioral in that the closer steps are about variables that are more intuitively associated with the shock, right? If I tell you about a supply shock, you can kind of think about inflation. If I tell you about an interest rate shock, you kind of think about interest rate. So the closer, you might just be intuitive. You might just be sort of cognitively constrained to only think about the closer steps. So that's one interpretation. There's actually a more like meta-rational, another explanation, which is to the extent this is a causal chain in that A affects B affects C affects D. If your perception, suppose your perception of all these chains are noisy, like say you have a cognitive noise, then if your perception breaks in the second step, then your perception of all the following steps stop being relevant because they're not activated, right? If A affects B affects C, if you don't perceive B, then you're not going to understand how C and D and E are going to change. So there is another interpretation more from sort of noise or robustness or like cognitive uncertainty type of thing. But we're not taking a particular stance on this.
All
right.
Thank you.
I hope that helps. I'm vastly over time. I'm sorry, Federico. I look forward to hearing the next presentation.